Imagine you're lying under a very quiet night sky, and someone whispers that beyond the stars you see there is an ancient icy mist surrounding the entire solar system, like a blanket preserving secrets from the earliest times. At the far edge of the solar system, NASA has observed ancient ice fragments that may have once seeded life. From there we will travel with Voyager across the boundary of the Sun, listen to the faint signals of interstellar space, and then follow a new mission preparing to go beyond every limit humanity has ever reached. Right now, we will begin our adventure at the edge of the solar system, where a mysterious shell of ice called the Oort Cloud holds trillions of primordial fragments and is the source of dangerous long-period comets. The story of our cosmic home does not begin with the planets, nor with the sun, but with a silence so vast and ancient that even light struggles to remember its way through it. Far beyond the warm glow of our star, past the orbits of the known planets, past the frozen dwarfs and drifting debris of the Kuiper Belt, there exists a frontier wrapped in darkness, an unseen sphere that has never been directly photographed, yet casts the longest shadow over the fate of life on Earth. The Oort Cloud. It is a name whispered in astronomy like a half-remembered dream, a place more imagined than known, a realm of 1 trillion frozen relics suspended in a gentle gravitational sleep, tracing out a shell so wide it may take a beam of light a year to cross it. And yet, despite its distance, despite its silence, something from that remote shroud may have once reached out and touched Earth with catastrophic effect. 65 million years ago, long before humans gazed upward to wonder about the night sky, the world belonged to giants. Forests trembled beneath the footsteps of thunder lizards. Oceans swarmed with predators of impossible size. Life thrived, sprawled, roared, and ruled without fear until a single blazing object streaked across the heavens and rewrote the destiny of the planet in the span of moments. Many of us learned that it was an asteroid that ended the age of the dinosaurs, a rocky bullet fired from somewhere between Mars and Jupiter. Yet a growing body of scientific thought whispers another possibility. What if the object was not a child of the inner solar system at all, but a visitor from the deep? What if it came from that distant cloud of ice and ancient debris, the Oort Cloud falling inward after millions of years of silence? Even now the idea stirs a quiet unease, because if it happened once, could it happen again? Imagine for a moment a vast cosmic orchard surrounding the solar system, each fruit icy, ancient, dormant. All it takes is one subtle tremor of gravity, the passing of a wandering star, a ripple through space like the faintest shiver of a cosmic breeze, and one piece of that ancient debris begins a long fall toward the sun, accelerating heating awakening. A frozen time bomb lit by physics alone. Some of these objects take hundreds of thousands of years to complete a single orbit, others millions. We call them long-period comets. They emerge into telescopes with no warning from no familiar path, like ghosts entering a room through the walls. They shine, they bloom into radiant tails, and sometimes they strike. But before fear comes fascination. Because the Oort Cloud is not a threat by intention. It is a library, perhaps the oldest one we have never touched. If the planets are the chapters in the book of our solar system's history, then the Oort Cloud is the dusty attic where the first drafts were left behind. To understand it, we must drift outward in our minds, past the sun's warmth where sunlight no longer feels like heat, but a memory, past the dance of planets where the solar system begins to thin into interstellar dust. Out there, gravity becomes a whisper. The sun's hold weakens, and eventually we reach the edge of its kingdom, a place where the pull of neighboring stars begins to compete with our own. There, in this twilight zone between ours and not ours, is where the Oort Cloud is believed to rest. No telescope has ever photographed it directly. No probe has ever touched it. Yet mathematics draws its shape for us, a spherical cloud surrounding everything we know, like a protective bubble and a cosmic vault. It may begin as near as 2,000 times the distance between Earth and the Sun, and extend outward to distances so great the numbers feel like poetry more than measurement. 50,000 astronomical units, perhaps 100,000. In that space, trillions of icy bodies, comets, frozen rock, primordial compounds float in fragile orbits, waiting for something to disturb them. But to truly feel the Oort Cloud, one must slow their breathing. Picture a darkness so complete it softens thought. Picture icy bodies drifting in a perpetual sleep so deep that time itself loses meaning. A place where silence reigns, not because there is no sound, but because sound has never been born there. As comforting as that stillness may seem, there is a quiet tension in it as well, for within this cosmic cradle lies the possibility of change. If life on Earth began under the calm of a golden sun, it may yet face endings from the cold of this unseen frontier. And recently, something stirred within that darkness, something larger than anything we have recorded from such distant origins. A megacomet named Bernardinelli Bernstein now journeys inward. Not a small visitor, not a passing traveller of modest scale, but a behemoth nearly 85 miles across. 10 times wider than the object believed to have ended the dinosaurs. Its presence alone challenges our understanding of Oort Cloud bodies and of what might be sleeping out there. And as astronomers observed it, something even more unusual appeared, jets of carbon monoxide erupting from its surface, despite being still unimaginably far from the sun. We will return to it soon. For now, gently let us drift back to where it all began. 4.5 billion years ago, the sun ignited into being, and the early solar system was a place of violence. Space was filled with debris collisions, fragments, ice and rock swirling in chaos. The giant planets, Jupiter, Saturn, Uranus, Neptune, moved like titans in a dance of gravitational upheaval. With each shift, each migration, their immense pull flung debris outward in all directions. Some fragments escaped the solar system entirely. Some spiraled back inward, colliding and merging into shapes that would become moons, asteroids, or planets. But most were cast outward, away from everything we would ever come to know as home. Far beyond the light, beyond the planets, until the sun's pull weakened enough for other stars to take part in a slow celestial tug-of-war. There these fragments settled, forming the sphere we now call the Oort Cloud. They are untouched relics, pieces of the early solar system, frozen in time, unchanged for billions of years. Imagine holding such a fragment, touching something that has not been warmed by sunlight since before Earth had oceans, before life breathed, before continents drifted, a time capsule of origins. This is why the Oort Cloud is not only a harbinger of risk, but a promise of knowledge. If ever humanity could reach those icy relics, we might hold in our hands the earliest materials from which our planets were made. We might learn not only how our world formed, but why life chose this place to bloom. And yet, every gain seems paired with a shadow, because from that same reservoir of ancient cosmic debris, objects sometimes fall inward, and those falls can be catastrophic. Scientists estimate that long-period comets are responsible for some of the most devastating impacts in Earth's history. Their speed, their unpredictability, their rarity make them the silent wildcards of the cosmos. Asteroids give warnings years, decades, even centuries. Comets from the Oort Cloud may reveal themselves only months before arrival. Like an unexpected knock at the door late at night from someone you do not remember inviting. For all our telescopes and sky mapping systems, the Oort Cloud remains a blind spot. Not because we do not look, but because light from that distance is too faint to return. In a sense, the Oort Cloud watches us, but we cannot yet watch back. Still, science advances. Some models now explore the idea that stars passing near the solar system every few million years may shake the Oort Cloud slightly, sending waves of comets inward. The gravitational tide of the Milky Way itself may also create cycles, eras of relative calm and eras of sudden celestial rain. If this is true, then Earth's history of extinction may be tied to the rhythm of the galaxy. An unsettling idea perhaps, but also a poetic one. For if life blooms and fades with the beat of the cosmos, then our existence is not random. It is part of a cycle written into the galaxy itself. Picture it slowly, the solar system orbiting the galactic center, taking roughly 200 million years to complete a single revolution. As we travel through the Milky Way, we pass through regions of varying density, star clusters, dust lanes, and perhaps cosmic hazards. Could it be that every so often, as our solar system drifts through certain neighborhoods of the galaxy, the Oort Cloud is disturbed and comets fall inward like a quiet rain? No certainty, only whispers of possibility. And yet possibility shapes curiosity. It invites exploration. It gives science the spark that turns into discovery. Softly now, let us return to the present, to the quiet around our world tonight. The sky above seems calm, but above the calm is the unknown, and in that unknown an ancient cloud of frozen relics waits at the edge of the sun's reach. As you listen, imagine the darkness between stars. Imagine the stillness of a comet suspended in ice for eons until one moment, imperceptible, delicate, it begins to move. A fraction of a fraction, a shift so small it would seem like nothing at all. But gravity is patient, and time in the Oort Cloud is endless. A journey begins long before anyone notices, And perhaps somewhere right now, another such fragment has just started its fall inward, beginning a voyage that will take millions of years before it reaches the warmth of the inner solar system. A journey that will outlast civilizations, languages, oceans, perhaps even the continents themselves. In this idea, there is both humility and wonder. We, the observers of the cosmos, exist for a breath-watching processes that unfold over spans beyond comprehension. Yet we are fortunate enough to witness a moment when one such traveller is already on its way, Bernardinelli Bernstein. As it approaches, we turn our instruments toward it, hoping to learn not only about its composition, but about its birthplace, about that unseen cloud, about the origins of everything we know. If the Oort Cloud is the cradle of comets, then each comet we observe is a messenger. One message at a time the universe speaks. And as the night deepens and your breath steadies, you may begin to feel a gentle shift inside the awareness that our place in the cosmos is at once delicate and extraordinary. We are sheltered beneath a star, yet surrounded by ancient ice that drifts in the dark as if waiting to be remembered. Some part of you may sense that the story of the Oort Cloud is not one of fear, but of connection. A thread weaving the past of our solar system to our present moment. A reminder that life emerges in fragile places and that every cosmic threat may also be a cosmic clue. Let this thought settle quietly. Perhaps the same icy bodies capable of ending worlds may also have delivered the ingredients to start life on ours. If you let your mind drift once more to the outer edge of the solar system, you may begin to sense the scale of what surrounds us. The Oort Cloud is not a thin ring nor a scattered patch of objects like the asteroid belt or the Kuiper belt. It is a vast spherical cocoon. Scientists believe its inner boundary may begin around 2,000 astronomical units from the Sun, 2,000 times the distance between Earth and the star that gives us warmth, and from there it may extend outward to 50,000, perhaps even 100,000 astronomical units. At such distances, sunlight becomes so faint that it carries almost no heat at all. A grain of light would take a year or more to cross that space. Within this immense sphere, astronomers estimate there could be as many as 1 trillion icy bodies. Picture a trillion silent travelers, each no larger than a mountain, or as small as a boulder suspended in an almost eternal night. A trillion is a number difficult to hold in the mind. It surpasses the number of stars in the Milky Way, and yet those icy fragments remain there waiting, as if time itself has paused around them. They are the untouched remnants of the solar system's beginning, a frozen archive billions of years old. These objects are not like the asteroids that inhabit the inner solar system. Asteroids tend to be rocky metallic, shaped by collisions and solar heat. The children of the Oort Cloud are made of ice dust, frozen gases, materials that formed when the solar system was still a swirling disk of chaos and creation. While planets grew and moons formed, these fragments were flung outward, pushed by the gravitational force of the giant planets. Jupiter, Saturn, Uranus, and Neptune acted like cosmic catapults. They hurled debris into the deep, sending countless icy bodies far from the sun, out to the unseen frontier. Most of those fragments remained there, held loosely by the sun's gravity, but always at the edge of escape. And it is this fragile balance that makes the Oort Cloud such a place of wonder. It is both a boundary and a threshold, a borderland between the sun's domain and the gravitational influence of other stars. In that delicate region, a gentle nudge, a passing star, a disruption in the galactic tide may be enough to change everything for one silent comet. When such a shift occurs, the long descent begins. A body that once slept in the darkness starts an orbit inward, slowly at first, then faster falling toward the sun. Some of these journeys can take tens of thousands of years, some millions. These objects are what we know as long-period comets, with orbits longer than 200 years. While short-period comets return often enough to become familiar visitors like Halley's Comet, with its 76-year cycle, long-period comets arrive like strangers unseen for entire eras of human civilization. They can approach from any direction in the night sky because the Oort Cloud surrounds the solar system like a sphere. One moment, nothing. The next, a faint new light appears in a telescope, and astronomers know that a traveler has returned from the edge of the sun's reach. These comets often travel at tremendous speeds, tens of thousands of miles per hour, faster than most asteroids. And because they approach from such distances, we may only have months of warning, sometimes less. Asteroids, by contrast, reside in orbits we can track. Their paths are mapped, monitored, calculated. But comets from the Oort Cloud do not follow easy patterns. They emerge suddenly from darkness with little time to prepare. It is this unpredictability that makes them both fascinating and feared. 65 million years ago, the world changed dramatically. The object that struck Earth and ended the era of the dinosaurs carved a crater, over 180 kilometers wide on the Yucatan Peninsula. The Chicxulub impactor, as it is now called, is widely estimated to have been between 6 and 9 miles in diameter. For decades, the common belief was that it was an asteroid, but a growing body of research now suggests another possibility, that it may have been a long-period comet, possibly from the Oort Cloud itself. If so, the story becomes even more haunting. Jupiter, often seen as Earth's protector because it absorbs or deflects many hazardous objects, may have played a double role. Some studies propose that Jupiter's enormous gravity could have pulled a comet inward, fragmented it, and sent one of the pieces toward Earth, a guardian and at the same time the unintended hand that delivered catastrophe. This idea remains a hypothesis, yet it reminds us that the solar system is a system of balance, not certainty. The Oort Cloud holds both threat and beauty. It may have brought destruction to Earth once, but it may also have brought life. Within the icy material of comets lie the building blocks of biology, water, carbon compounds, organic molecules. Many scientists believe that comets striking the young Earth could have delivered some of the essential elements that helped life emerge. If true, then the Oort Cloud becomes more than a distant threat. It becomes a cradle of possibility, a cosmic paradox, life and death drifting side by side. This duality becomes even more intriguing when we consider the recent arrival of Bernardinelli Bernstein, the enormous comet discovered in 2010. Its sheer size captures the imagination. Measuring nearly 85 miles or approximately 137 kilometers across, it dwarfs the Chicxulub impactor. It is so large that some astronomers suggest it sits on the boundary between comet and dwarf planet, and it is still on its way inward. But size is not the only reason Bernardinelli Bernstein draws attention. While still more than halfway to Neptune at a distance of around 16.6 astronomical units, a surprising discovery was made. Using the powerful Atacama Large Millimeter Submillimeter Array in Chile, scientists detected activity on the comet. Streams of carbon monoxide gas CO were observed erupting from its surface. This is extraordinary, because most comets do not become active until they are much closer to the Sun, typically within the orbit of Jupiter. Activity is usually driven by the sublimation of water, ice turning directly into vapor as it warms. But Bernardinelli Bernstein began releasing gas while still in the deep cold of the outer solar system. At such distances, sunlight is too weak to melt water ice. Instead, the activity appears to be driven by far more volatile substances like carbon monoxide or other exotic ices that vaporize at extremely low temperatures. These exotic ices offer a clue to the ancient chemistry of the solar system. If this comet is indeed a preserved fragment of the early days of planetary formation, then studying it could reveal what kinds of materials existed before the planets formed. It is like finding a sealed container from the dawn of the solar system, still unopened, still pure. Some scientists now wonder if Bernardinelli Bernstein carries materials we have never observed before. What else might be hidden in the Oort Cloud? What unknown compounds sleep within that reservoir of ice? What secrets of origin lie in wait, frozen in silence? And another question arises, soft but persistent. If comets carry volatile ices capable of releasing energy so far from the Sun, could these outgassing events subtly change their paths? Outgassing creates what are known as non-gravitational forces, small but real, like tiny thrusters pushing ever so gently. In most comets, these pushes are noticeable enough to slightly alter orbits, yet Bernardinelli Bernstein is millions of times more massive than a typical comet. For an object of its size, such outgassing would produce only the faintest adjustment to its course, not enough to cause concern, not enough to redirect it toward Earth. Even so, the thought lingers, a cosmic giant stirring. This is the nature of the Oort Cloud. It invites questions that stretch the imagination. Questions rooted in science yet tinged with wonder. As you listen, allow the thought to settle gently. We live inside a bubble of space surrounded by a distant cloud we have never seen, but which has shaped the history of our world. A cloud that may have delivered both the ingredients for life and the instruments of extinction. A cloud that now sends as a messenger a colossal comet that will pass quietly through the outer solar system, offering us a chance to learn more than we ever have before. It is humbling to consider how little we know. For all our telescopes, our probes, our satellites, we remain children of the inner solar system. No spacecraft has ever reached the Oort Cloud. Not Voyager 1, not Voyager 2, not Pioneer, not New Horizons. The Oort Cloud has never been touched by anything we have built. The most distant object we have ever sent, Voyager 1, will take roughly 300 years just to reach the inner edge of the Oort Cloud, and to travel through it entirely could take around 30,000 years. Imagine that. If someone today carved a message onto a plaque and placed it aboard a spacecraft, that message would be older than the pyramids by the time it left the Oort Cloud. In this perspective, our entire history feels brief. Our civilizations, our stories, our dreams, small flickers of warmth beneath a sun that itself is only one star among billions. Yet this smallness is not sorrowful, it is peaceful. In the stillness of cosmic scale there is comfort. Like standing by the sea at night, hearing the waves beyond the dark, knowing the world is vast and somehow that vastness brings calm. As the mind begins to quiet, you may sense the Oort Cloud not as a threat, but as a gentle reminder of where we come from, of how extraordinary it is that life emerged here at all. We are shaped by cosmic history whether we notice or not. The atoms in our bodies were forged in stars. The water in our cells may have come from comets. Perhaps the spark of biology itself was carried here on icy messengers long ago. And now, as we observe Bernardinelli Bernstein, we watch not with fear but with curiosity. What will it reveal? What story will it tell? When its gases drift, when its ice is warm, what ancient secrets may rise into space like whispers of a time before planets? Science will measure, instruments will record. But beyond the data, there will be a quiet sense of connection, a feeling that the universe is not distant, but deeply intertwined with our existence. Let your breathing soften. Picture the Oort Cloud, once more a faint sphere drawn by imagination wrapped around the solar system, like the memory of a snow globe's shell. Within that shell, 1 trillion icy bodies float. Some will remain asleep for eternity. Some may fall inward and burn in the sun, and a few rare and luminous may cross the night sky long after we're gone, becoming legends for future eyes. Perhaps in some far future humanity will no longer watch from Earth. Perhaps children of Earth will voyage outward toward the Oort Cloud itself, not with fear but with wonder, with the dream of touching that ancient ice, holding the oldest material our solar system has ever known, and in that moment we may feel not like observers of the universe, but participants in it. For now though, the Oort Cloud remains a mystery, silent, waiting, a guardian of beginnings, a keeper of endings, and above all a reminder that the story of our solar system is still unfolding. As you rest with these thoughts, one gentle question lingers in the mind, soft as stardust. If something as distant and unseen as the Oort Cloud has shaped the fate of life on Earth, what other unseen forces cradle our existence even now? Let that thought stay with you lightly. Like a comet's tail, faint against the night sky, brief, beautiful, and full of quiet meaning. There is a moment when we look out at the night sky that we forget how little of the universe we have truly touched. For all our centuries of star watching, for all the observatories and telescopes pointed upward, humanity has physically travelled only the smallest fraction of the space around us. Yet there came a time, not so long ago, when we decided to reach beyond the familiar orbits of the planets, to cross the threshold where the sun's warm breath fades into silence. The story of that journey begins on our own world under the bright skies of the late 1970s, when Earth was a very different place. The Cold War held nations in tension. Technology was young. Computers were fragile, rare, and unimaginably limited by today's standards. But for a brief moment in cosmic time, the solar system gifted us an opportunity that would not return for another 175 years. The 4 giant planets, Jupiter, Saturn, Uranus, and Neptune, aligned on one side of the Sun. Such alignment is not merely an arrangement of beauty. It forms a path, a gravitational staircase allowing a spacecraft to leap from one world to the next, using a technique called a gravity assist. Like a stone skipping across a calm lake, a probe could borrow momentum from each planet it passed, gaining speed without fuel. If timed precisely, a single spacecraft could visit all 4 giant planets in one extraordinary expedition. NASA called this vision the Grand Tour. Engineers, dreamers, and scientists gathered to design a machine capable of seizing that fleeting window. It would need to survive the radiation of Jupiter, the icy winds of Saturn, and the lonely darkness beyond. It would have to travel farther, faster, and longer than any probe before it. The result was 2 identical spacecraft conceived under the name Mariner Jupiter-Saturn, later renamed with a word that would echo across history: Voyager. Voyager 2 launched first on August 20th, 1977. Voyager 1 followed soon after on September 5th, 1977, taking a faster trajectory that would allow it to overtake its sibling in space despite launching second. They carried technology that by today's measure seems impossibly small. Each Voyager held a computer memory of just 69.63 kilobytes less storage than a single image on a basic phone today. A modern digital watch processes information tens of thousands of times faster, and yet this limited, delicate technology would endure beyond every expectation, surviving the cold vacuum for decades. What Voyager lacked in memory, it carried in meaning. Fixed to each spacecraft was a carefully crafted gift, the Golden Record. A gold-plated copper disc engraved with greetings in 55 languages, a selection of the Earth's music, natural sounds, whale songs, brainwave recordings and photographs encoded in analog form. It was a time capsule and a message, our way of saying we were here, we lived, we wondered. The hope was simple and profound. If a distant civilization ever found Voyager drifting in the darkness, they would know that Earth held life that sang, loved, dreamed, and longed to understand the stars. As the Voyagers left Earth behind, they carried not just instruments, but a quiet promise. A promise that humanity would reach beyond the cradle of our world into the unknown. The journey to Jupiter was swift by cosmic standards. Voyager 1 arrived in 1979, capturing images that stunned the world. Jupiter was no longer a blurred dot in the sky, but a swirling giant of storms, color, and motion. The Great Red Spot, a hurricane larger than Earth itself, revealed patterns and details never seen before. And around Jupiter, new moons were discovered, worlds that had been invisible to our eyes until then. One of the most dramatic discoveries came from the moon Io. Voyager caught sight of a plume rising from its surface, an eruption. It was the first active volcano ever observed beyond Earth. A world alive with fire, locked in a dance of tidal forces. With Jupiter reminded us that the solar system still breathes with energy. Voyager 2 followed, capturing images that allowed scientists to create time-lapse views of Jupiter's atmosphere. The colors, the storms, the winds, everything moved with a rhythm that felt almost alive. For the first time, humanity witnessed the true nature of a gas giant's weather, powerful, restless, ancient. From Jupiter, the Voyagers rode the gravitational current towards Saturn. Voyager 1 reached it in 1980 and Voyager 2 in 1981. Saturn greeted them as a world of elegance encircled by rings that seemed delicate as frost crystals. But Voyager revealed that the rings were not single bands, they were composed of hundreds of narrow structured layers shaped by forces still not fully understood. Saturn's moon Titan became a turning point. Wrapped in a thick, hazy atmosphere opaque to visible light, Titan refused to reveal its surface. But instruments detected temperatures near the triple point of methane, where methane can exist as solid, liquid, or gas. It was a clue that lakes and rain of methane might shape its surface just as water shapes Earth. Titan felt like a world with its own version of weather, perhaps even geology, a place that might hold secrets of chemistry relevant to the origins of life. Yet choices had consequences. Voyager 1 approached Titan closely, so closely that its trajectory bent away from the outer planets. In choosing to study Titan, it sacrificed the chance to visit Uranus and Neptune. Voyager 2 would continue alone to complete the grand tour. Still, Voyager 1's mission was far from over. Before its cameras were shut off forever, it turned back toward home. On February 14, 1990, more than 6 billion kilometers away, it captured a fragile image of Earth, a tiny speck of blue suspended in a sunbeam. The pale blue dot, just 0.12 pixels in size, Carl Sagan later reflected on a mote of dust suspended in a sunbeam. The image became a mirror for our humility. All our triumphs, conflicts, histories contained in a single trembling point of light. Voyager 2, meanwhile, pressed on. It reached Uranus in January 1986, becoming the first and only spacecraft to visit the pale blue world. Uranus revealed itself as an ice giant, composed not primarily of hydrogen and helium like Jupiter or Saturn, but of water, ammonia, methane, and hydrogen sulfides swirling in a cold interior. It rotated on its side, tipped dramatically, perhaps due to a colossal collision in its distant past. It was colder than expected, even colder than Neptune at times, a world of calm, muted tones holding mysteries beneath its gentle blue atmosphere. Next, in August 1989, Voyager 2 arrived at Neptune, the 8th and farthest planet in the solar system. Its winds roared at speeds among the fastest in the solar system. There, Voyager discovered Triton, a moon with geysers of nitrogen erupting from its frozen surface. Neptune, once only a point of data, now stood before humanity as a world of storms, ice, and motion. With Neptune behind it, the grand tour was complete. Voyager 2 had visited all 4 giant planets. No spacecraft had done so before, none have done it since. And then came the long silence of interplanetary space. The Voyagers continued out with their cameras now turned off to save power, leaving only instruments to listen to the invisible. Years passed, decades passed. The sun grew smaller and dimmer behind them. They were moving not just through distance, but into a new realm toward the very edge of the solar system's influence. To understand what they found there, imagine the sun not as a ball of fire, but as a source of wind. Solar wind streams of charged particles flows outward in all directions, creating a protective bubble around the planets. This bubble is called the heliosphere. Within it, solar particles dominate. Beyond it, the environment belongs to the galaxy, where cosmic rays from distant stars and ancient supernovas roam freely. For much of history, scientists believe the solar wind simply faded, gradually thinning into nothing. But the Voyagers would reveal a far different truth. Voyager 1 reached the boundary in August 2012. Instruments recorded a sudden drop, 1,000-fold decrease in particles from the sun. At the same time, galactic cosmic rays rose by 9%. It was a sharp line, not a gradual blend. This boundary is called the heliopause. On one side, the sun's influence, on the other, interstellar space. The heliopause was not smooth, it rippled, it shifted. Later, Voyager 2 would cross it as well, 6 years after Voyager 1, confirming that the boundary moves swayed by pressures we still do not fully understand. This discovery alone reshaped astronomy. The sun does not simply fade, it pushes against the galaxy, creating a bubble that shields every living thing inside it. Without the heliosphere, Earth would be struck constantly by high-energy, cosmic radiation that could damage DNA, disrupt atmosphere chemistry, and perhaps prevent life as we know it from thriving. And yet at the edge of this protective bubble, something unexpected was recorded. The density of plasma outside the heliopause was higher than predicted. Not by a small margin, but significantly. Models had estimated about 0.037 particles per cubic centimeter. Voyager measured 0.0329, then later readings rose to 0.12, more than triple the expected value. It was as if there was a traffic jam of charged particles. Solar plasma colliding with interstellar plasma piling up at the boundary, pressed together by cosmic forces. The interstellar magnetic field was also discovered to be 2 to 3 times stronger than scientists had believed, implying that interstellar space exerts 10 times more pressure on our heliosphere than models had assumed. The more the Voyagers observed, the more the edge of our solar system seemed less like an ending, and more like a transition zone, a frontier shaped by interactions, collisions, and invisible forces humming through space. And here gently a question begins to form: if the heliosphere is a bubble, then what lies beyond the bubble? The answer would come later with the discovery of something called the local bubble. But for now, let us remain with the Voyagers drifting just beyond the sun's final reach. As the spacecraft journeyed deeper into interstellar space, they continued sending data back to Earth. Their signals traveled more than 20 hours each way, tiny whispers so faint that by the time they reached us, their power was weaker than the energy of a falling snowflake. Yet the deep space network heard them, space. And then unexpectedly the silence came. The silence arrived like a fading breath, soft at first, then unsettling. For decades, Voyager 1 had spoken to us across the void, whispering data from regions no human eye had ever seen. But in late 2023, its voice began to distort. At first, the signals seemed scrambled, then fragmented, and then nothing coherent at all. Bits that once carried measurement and meaning deteriorated into patterns with no structured data that could not be read, interpreted, or trusted. Astronomers and engineers at NASA listened as if attending the bedside of an aging traveler who had journeyed far beyond the horizon of home. Voyager 1 was the most distant human-made object in existence, over 24 billion kilometers away. Any command sent to it required more than 22 hours to arrive. Any response would take just as long to return. In human terms, repairing such a craft would be impossible. There would be no rescue mission, no astronaut to tighten a bolt or replace a failing chip. The spacecraft was operating with hardware older than most of those now caring for it, hardware never designed to last nearly half a century. Still, they did not give up. For months, Voyager 1 continued to transmit only gibberish streams of zeros and ones that no longer aligned with any known data format. Engineers traced the problem to a failing Flight Data System (FDS) memory module. A section of memory that stored the code used to package telemetry had begun to degrade like a page of a book, fading under time. In April 2024, after long calculations, NASA issued a delicate sequence of commands instructing Voyager to relocate the corrupted code to a different section of memory, an area never originally intended for such use. Tens of billions of kilometers away in the deep cold between stars, the command reached Voyager. Slowly, almost shyly, a coherent signal returned. For the first time in 5 months, Voyager 1 spoke clearly again. Humanity exhaled. A machine built in the 1970s with less memory than a digital alarm clock had survived a kind of cosmic stroke and recovered. It felt symbolic, as if the universe had allowed the traveler to continue just a little farther. But we know the truth that lies beneath this moment of relief. Voyager is aging. Its generators, which convert heat from radioactive decay into electrical power, are weakening. Instruments continue to shut down one by one to conserve energy. A time will come soon when the last instrument falls silent, when the last whisper returns home. Even after that silence, Voyager will continue to sail. It will drift through interstellar space for tens of thousands of years, passing near distant stars long after human languages, nations or constellations may have changed. In about 40,000 years, Voyager 1 will pass within 1.6 light-years of a small star known as AC plus 79 through Theseus 88 in the constellation of Camelopardalis. Voyager 2, taking a different path, is headed toward a close encounter with Ross 248, a dim red dwarf, in roughly the same span of time. Both spacecraft will keep going, quiet, alone, eternal wanderers between suns. There is something profoundly poetic and gently sorrowful in knowing that a machine forged by human hands will outlive nearly everything humans have built. Civilizations will rise, transform and fade, while Voyager continues its journey unchanged, untouched. A silent envoy of a species that dared to look beyond its sky. And yet the Voyagers are more than metal and circuitry. They represent a turning point in our understanding. They allowed us to redefine the borders of home. Before them, human consciousness was confined to the inner solar system. After them, the idea of space expanded. The solar system was no longer a map with the planets as its edge. It became a place with depth layers, thresholds, and a frontier that breathes. The discoveries the Voyagers made at the heliopause were especially transformative. The heliosphere, the bubble formed by the sun's solar wind, once seemed like a vague concept in textbooks. But Voyager's instruments transformed that theory into reality. They revealed the termination shock, the heliosheath, and finally the heliopause as distinct regions, each with its own physics. The termination shock was the first boundary where the solar wind racing outward at supersonic speeds abruptly slowed as it collided with the thin gas between stars. Beyond it lay the heliosheath, a turbulent region of swirling plasma, where solar wind struggled against cosmic forces pressing inward. Only after crossing this storm-like transition did Voyager reach the heliopause, the true boundary, where the sun's influence faltered and the galaxy began. Inside the heliosphere, the sun is the storyteller. Beyond it, the galaxy speaks. And the galaxy speaks in plasma magnetism and rays of ancient origin. It was once assumed that space beyond the heliopause would grow quieter, calmer, thinner with distance. Instead, Voyager found denser plasma, stronger magnetic fields, and traces of events that may have happened millions of years before our species evolved. The interstellar medium, far from being empty, was alive with structure. By listening to the vibrations of plasma, Voyager detected waves oscillations like the soft hum of a cosmic instrument being played somewhere in the distance. These vibrations would later be interpreted as a tone of approximately 3 kHz recorded over years, a symphony so faint but unmistakably there. If Chapter 1 invited us to reflect on the icy origin of comets and the outer edge of the sun's material legacy, Chapter 2 asks us to listen to hear the story of the solar system's skin, the barrier between us and the galaxy beyond. And in listening, a sense of perspective settles gently into the mind. Earth is not alone in space. It is sheltered, wrapped inside the sun's protective bubble. The heliosphere functions almost like a cosmic cocoon, absorbing and deflecting harmful galactic radiation. It shields the planets, our moon, and every living thing that has ever walked the Earth's surface. Without it, cosmic rays, high-energy particles born in the furnaces of dying stars, would pour through the solar system in greater intensity. The conditions for life, especially delicate biological life, might have been very different. It is humbling to imagine that our entire history, every breath ever taken, occurred inside a bubble formed by the sun's wind. But now, as the Voyagers sail just beyond that edge, we glimpse the outside for the first time. We see that the boundary is not rigid but elastic. It swells and contracts with the sun's 11-year solar cycle. When the sun becomes active, the heliosphere expands, its winds growing stronger. When the sun grows quiet, the bubble recedes, allowing more cosmic radiation to filter in. The heliosphere is alive, pulsing, breathing, protecting, and this awareness gives rise to a tender thought. The sun is not only a star that warms us, it is a guardian, a silent protector, and we live within its embrace. Soon, humanity will need to confront a new question. What will our journey become when we step beyond that embrace? The voyagers have shown us the gate, but passing through a gate is not the same as exploring the land beyond it. For all their achievements, the voyagers are simple scouts, slow, passive drifting. They sense, they listen, but they cannot turn or return. They do not choose their path. Gravity chose it for them long ago. If we wish to truly explore interstellar space, a new kind of mission will be required. Faster, smarter, designed with intention, not as a byproduct of a planetary tour. A mission not meant to glance back at home, but to move forward into the unknown with purpose. For now, though, as you rest within this moment, imagine the voyagers continuing their silent travel. Picture them in the darkness, small silhouettes against a backdrop of stars, their thin antennas pointed back toward the pale blue dot that once launched them. Imagine their golden records untouched, still gleaming after decades of dustless flight. If an alien civilization were ever to find Voyager, perhaps thousands or millions of years from now, would they understand our message? Would they hear the greetings recorded in human voices, the sound of rain, wind waves? Would they feel the emotion in a Beethoven symphony? Or would they puzzle over the symbols, trying to interpret what kind of beings created such a gift? Even if the record is never discovered, its existence changes us. The act of sending it, of choosing what to include, forced humanity to define itself in a way we rarely do. Not by language borders, beliefs or differences, but by essence. We chose to be remembered as curious, creative and aware. There is comfort in that choice. A comfort that settles like dust in moonlight, gentle, weightless, beautiful. Now as you breathe in a slower rhythm, feel the softness of this reality. A tiny craft built by hands on Earth is out there now, still moving, still calling home. And in this simple truth lives a profound reflection. We are small, yet we reach. We are fragile, yet we endure. We are temporary, yet we imagine eternity. In the quiet that follows, you may begin to sense the next chapter, forming the idea that the heliosphere is not the only bubble surrounding us. That beyond the sun's protective shell lies another refuge, larger, older, carved by forces far grander than any solar wind. The local bubble. A vast cavern of low-density gas stretching 1,000 light-years across, formed by the explosions of ancient stars. A place where our sun drifts like a boat on a calm sea. A bubble within a bubble, cosmic, nesting like Russian dolls of space and time. But that is a story waiting, a whisper approaching, a doorway about to open. For now, let your thoughts settle like stardust across the mind. Feel the peace in the vastness, feel the softness of distance, and hold this simple awareness close. We have sent our voice into the dark, and the dark answered with wonders. There is a quiet comfort in believing that space is a silent place, a vast dark ocean where nothing stirs, nothing speaks, and nothing moves unless touched by force. For centuries, that is how humanity imagined the universe, calm, empty, and still. But the truth, as we are slowly beginning to understand, is that space is alive with motion, with pressure, with waves and whispers that travel through the dark, carrying stories older than Earth itself. To understand these whispers, we must first understand the bubble that cradles us. You may recall how Voyager slipped beyond the reach of our sun's wind, beyond the heliosphere, into interstellar space. Yet what exactly is this bubble that protects us, and what lies beyond it? Imagine the sun not only as a burning sphere of light, but as a heart that breathes. With every moment it exhales a constant stream of charged particles, solar wind flowing outward in all directions. This wind creates a vast bubble, a kind of shell that surrounds the solar system. Inside this shell, the sun's influence dominates. Outside it, the environment belongs to the galaxy. This shell is called the heliosphere. Within the heliosphere, the sun's wind shapes space. It carries magnetic fields, it sculpts the paths of particles, and it softens the harshness of the galaxy beyond. But like all bubbles, it has a surface and edge, a place where the inner world meets the outer. That edge is the heliopause, the boundary where the solar wind is finally stopped by the pressure of the interstellar medium, the thin gas and plasma that fill the space between stars. Until Voyager arrived there, most scientists believed the heliosphere faded, gradually dissolving into interstellar space like breath into cold air. But the Voyagers revealed something different. The boundary was not soft, it was not subtle, it was sharp, almost abrupt. On one side of the heliopause, particles from the sun were strong. On the other, they dropped by nearly 1,000-fold. At the same moment, cosmic rays from the galaxy increased. It was a clear line, a membrane between worlds. The heliosphere is not small. Its boundary lies roughly 120 astronomical units from the Sun, more than 3 times the distance of Pluto. And yet beyond that border lies something even larger, something that encloses not only the heliosphere but dozens of nearby stars as well. A second bubble, a far older, far grander cavity carved into the galaxy itself. Astronomers call it the local bubble. To picture the local bubble, imagine a vast hollow in the Milky Way, an enormous irregularly shaped cavity in the interstellar medium, stretching roughly 1,000 light-years across. Within it, the gas is thin, far thinner than average space in the galaxy. It is as if something once swept this region, clearing away clouds, dust and dense matter, leaving behind a low-density void. The leading theory is as breathtaking as it is humbling. The local bubble was created by a series of supernova explosions perhaps 14 million years ago from massive stars that lived fast and died violently. One explosion would not have been enough. It likely took around 15 supernovae detonating over millions of years, each one expanding, colliding and hollowing out the region until a vast empty space remained. Our sun was not born inside this bubble. It is believed to have drifted into the local bubble around 5 million years ago. At that time, early human ancestors were only beginning to walk upright on Earth. The journey of our star through the galaxy is slow, graceful, almost unnoticeable on a human timescale. Yet over millions of years, stars move, regions shift, and the sun entered this cosmic harbour, this strangely calm region of space. Some suggest this timing is not without meaning. Inside the local bubble, the low-density environment may have reduced exposure to certain types of cosmic radiation. It may have played a quiet role in shaping the conditions on Earth, conditions that allowed life not just to survive, but to flourish. We cannot say for certain, but the thought itself carries a softness like a blanket drawn around a sleeping child. A bubble within a bubble, the heliosphere inside the local bubble, the Earth inside the heliosphere, life inside the Earth. Layer upon layer of shelter like nested cradles. And if we listen closely in the way Voyager learned to listen, we discover that even in this quiet cradle of space there are sounds, vibrations, messages carried on waves of plasma and magnetism. Space is not silent. When Voyager 1 crossed the heliopause, its instruments detected something unexpected. A faint, steady tone, a plasma hum at around 3 kHz. It lasted not for moments or hours, but for almost 3 years. It was a quiet song, constant and unwavering, as if the space beyond the sun's reach was humming to itself. Of course, sound cannot travel in the vacuum of space. There is no air to carry it. But plasma-charged gas can vibrate, and those vibrations can be measured electrically, then converted into audio frequencies humans can hear. What Voyager recorded was not sound in the ordinary sense, but a translation of plasma wave oscillations into a tone. Still, the effect is mesmerizing. A lonely spacecraft drifting through the dark, hearing a soft, high-pitched note steady, unbroken like a cosmic tuning fork resonating in eternity. When scientists played the recording for the public, many described it as eerie, like a whisper from the void. Others felt comforted, as if the universe itself were breathing. Some even wondered, half in jest, half in awe, if the hum was a message. Science offers explanations rooted in plasma physics. As the spacecraft travels through regions of varying density, electromagnetic waves ripple through the charged particles, creating detectable tones. These tones shift as Voyager moves like wind changing pitch across a field of tall grass. And yet the emotional impact of hearing that hum is undeniable. There is something ancient in its simplicity, something soothing in the idea that even the emptiness between stars vibrates with energy. More mysteries followed. Fast radio bursts, FRBs, brief intense flashes of radio waves lasting mere milliseconds, were detected from distant galaxies. Some occur only once, others repeat. Their origins remain uncertain. Some may come from magnetars, highly magnetized neutron stars. Others might be produced by cosmic phenomena we do not yet understand. And a small but persistent branch of speculation wonders, if a civilization wished to send a signal across galaxies, would they choose radio waves, short bursts of focused high-energy transmission that could travel through space with little interference? We cannot conclude such ideas with certainty, but they live in the 25% of imagination you allow us to explore. Closer to home, even Mars has revealed its own curious sound, The Perseverance rover equipped with microphones captured an unexpected noise on the red planet, described by some as a high-pitched scratching or pinging sound. Scientists propose it may come from dust grains or interactions of wind with the rover's body. But the recording feels strange, almost alien when heard in the stillness of night. Space hums, Mars scratches, distant galaxies send out mysterious bursts of radio energy. The more we listen, the more the universe feels like a place filled with quiet signals layered like a symphony of invisible instruments. And as we lean closer to these whispers from the cosmos, a gentle shift begins inside us. For generations, humanity believed that silence was the default state of the universe, that stars burned without sound, that planets spun without voice, and that the space between them held nothing but emptiness. But Voyager, Perseverance, and our deep space observatories have revealed a different truth. The universe is not silent. It is full of subtle conversations. Some of these cosmic murmurs are natural, born of physics, magnetism, and the restless dance of charged particles moving through space. Others feel less easily explained. Not impossible, not supernatural, simply unexplained, for now resting in that delicate space between what we know and what we have yet to understand. Within the protection of the heliosphere, Earth has been shielded from much of this cosmic chorus. It is like living inside a quiet room, walls padded against the noise outside. For billions of years, life evolved here, sheltered by the sun's magnetic field, wrapped inside the bubble of its wind, hidden within the local bubble like a pearl inside nested shells. Only now, with our instruments finally reaching beyond the walls, do we realize how much lies beyond our former hearing. Imagine for a moment floating alongside Voyager, gently as if carried by a slow current. The sun has shrunk behind you to a pale star. The planets you once knew are invisible, now swallowed by distance. Ahead, the darkness seems endless, but your instruments detect faint tremors in the plasma around you. You hear a soft, constant tone like a sustained note on a violin string, neither rising nor falling, simply being. That hum may come from the density of plasma vibrating in the interstellar medium, perhaps energized by ancient shock waves, remnants of supernova explosions, whose echoes still ripple through this region of our galaxy. When we convert these plasma oscillations into sound, they reach the human ear as a thin, ethereal whistle, high-pitched, delicate, and strangely soothing. This sound is not meant for us, and yet somehow it feels as if we were meant to hear it. Perhaps because hearing it reminds us that we are part of something bigger, that the universe is active, dynamic, and alive with movement even in the quietest corners. There is a poetic symmetry here. Just as whales sing across oceans, their voices traveling through water across great distances, the galaxy too seems to carry its own songs through plasma. Not sound in the ordinary sense, but a transmission of energy across the cosmic sea. Scientists have tried to understand whether these tones carry structure beyond physics, patterns, layers, anything that might hint at intentional transmission. So far, all evidence suggests natural origins, but the mere question reveals a shift in our thinking. We are beginning to listen not just for noise, but for meaning. The discovery of repeating FRBs fueled that curiosity. Some of these bursts originate billions of light years away, so far that the signal we receive today began its journey before Earth had mammals. Yet they arrive with a clarity that defies the distances they cross. When a repeating FRB was detected, a signal that fired again and again from the same point in space, it challenged the idea that all such bursts were random. It suggested cycles, patterns, rhythms. Most likely these come from magnetars, neutron stars whose magnetic fields are trillions of times stronger than Earth's. The energy they release can distort space itself. In the language of science, that is explanation enough. But in the quiet hours of night, when one listens to the recorded bursts, sharp and sudden, one after another, like someone knocking gently yet urgently on the cosmic door, imagination stirs. Not with fear, not with assumption, only with possibility. And possibility is the birthplace of curiosity. We stand now at the beginning of a new phase of listening. For the first time in human history, we're hearing the universe from outside our sun's influence, outside the noise of our own cosmic neighborhood. And it is changing how we see ourselves. Inside the heliosphere, the sun is our dominant force. But beyond it and beyond the local bubble, other voices rise. Energies from distant stars, winds from supernovae currents, shaped by the galactic magnetic field. Our solar system is not alone in its movement. It is part of a grander tide. The local bubble itself is not static. It is a cavity surrounded by walls, denser regions of gas and dust sculpted by the shock waves of those ancient supernovae. As the sun travels through this vast chamber of space, it approaches those edges slowly. In time, perhaps millions of years from now, it may reach the bubble's boundary and enter a denser region of the galaxy. When that happens, the heliosphere may shrink, cosmic radiation may increase, and the climate of Earth could subtly shift. Life on Earth over its long history has been shaped by cosmic circumstances. Geological records show periodic changes in extinction rates and biodiversity that some researchers link to the solar system's journey through the galaxy, through spiral arms, dust lanes, star-forming regions, and perhaps boundaries between cosmic bubbles. If true, then evolution itself may be influenced not only by earthly forces, volcanoes, climate, oceans, but also by the slow drift of our solar system through the Milky Way. The thought brings a softness, a sigh of wonder, that the rise of forests, the fall of species, the branching of life across the tree of evolution may carry echoes of cosmic geography, that our story is not confined to Earth, but written into the galaxy itself. And as this realization settles, a gentle question emerges. If the universe is filled with waves, tones, and signals, if space itself sings, then what is the melody we are meant to hear? Not the literal sound, not a message in words, but the meaning behind the presence of motion, energy, and resonance in what we once thought was silence. Perhaps the universe is not asking to be decoded. Perhaps it is simply reminding us that we are part of its music. The sun hums. The Earth resonates with magnetic storms and auroras. Planets whisper through radio emissions. Jupiter and Saturn produce electromagnetic choruses, heard by passing spacecraft, rippling hypnotic sounds like choirs of cosmic wind. The Milky Way emits a faint microwave background, a leftover glow from the birth of time. The universe has sung since its beginning. We are only now learning how to listen. Let this awareness soften your breath, slow your pulse, and ease your mind. Feel the warmth of knowing you live inside not one but multiple layers of shelter. The Earth's atmosphere, the magnetosphere, the heliosphere, and the local bubble. Each one a cocoon, a cradle, a quiet space where life could take root. Outside these layers lies not danger alone, but depth, wonder, and the promise of connection. And in this moment, as you rest, imagine that you're floating between these bubbles, drifting gently like a leaf on a calm cosmic tide. You feel the sun's protection behind you, the galaxy's vastness ahead, and all around you, the faint vibration of a universe that is never still. You are not separate from it. You are within it, you are made of it, and the universe is whispering. As our awareness of these cosmic whispers deepens, a new understanding begins to form like a constellation, slowly taking shape in the night sky. We start to realize that the universe does not speak with one voice, but with many. Each phenomenon, each hum, burst, tone, or vibration belongs to a wider language of energy, movement, and memory that spans across cosmic scales. The local bubble within which our entire solar system drifts is not empty silence. Though the gas inside it is thin, the walls that surround it, the edges carved by supernova explosions long ago, hold traces of ancient violence. The boundaries of the bubble are thought to be rich with denser gas dust and magnetic fields that still carry the echoes of those stellar deaths. If we could hear them, perhaps they would sound like the fading aftershocks of distant thunder. We have long believed that life thrives only within safe harbors, within bubbles that shield us from harm. But what if curiosity requires us to eventually step beyond them? Just as Voyager crossed the heliopause, one day, humanity may reach the boundary of the local bubble itself. Scientists estimate that we will drift closer toward one of its edges over the next few million years, and when we cross it, the cosmic environment may change in ways that shape our planet and its story once more. For now, we remain inside listening. The 3 kHz plasma hum Voyager heard was only the beginning. As our instruments tuned themselves to new forms of perception, other signals emerged. Some were subtle, soft, and almost meditative. Others were sharp, brief, and electrifying, like someone tapping quickly on the cosmic glass separating one realm from another. These sharp bursts, fast radio bursts, or FRBs are among the most mysterious. They last for only a fraction of a second, yet in that instant release more energy than our sun emits in days. Many are one-time events, but a few repeat from the same point in the sky. These repeating FRBs behave like lighthouses, flares, that blink from a fixed location across cosmic distances. Some follow irregular schedules, while others follow cycles hinting at a natural mechanism beneath the mystery. The prevailing scientific theory remains grounded. FRBs are likely linked to magnetars, super-dense remnants of stars with magnetic fields, so intense they could erase data on a hard drive from half the distance to the moon. When these magnetic fields twist or fracture, energy is released in explosive bursts of radio waves that tear across space. Natural, powerful, and astonishing. And yet a hypothesis exists, soft, speculative, but persistent. If you were an advanced civilization trying to send a signal across galaxies, you would need something powerful, something that could travel unimpeded through dust gas and the static of stars. Radio waves, short, controlled, purposeful, would be one of the most efficient choices. A repeating pattern would draw attention. A location-based pulse would be identifiable. A burst strong enough to travel billions of light years would be necessary. Of course, we do not jump to conclusions, but sometimes curiosity hums softly at the edges of reason. The same gentle curiosity touches the sounds captured on Mars. Unlike the vacuum of space, Mars has a thin atmosphere, so sound can travel there but differently than on Earth. The Perseverance rover recorded the wind, the movement of dust devils, and the mechanical sounds of the rover itself, but among them there were hints of something unexpected, subtle tapping, scratching, or pinging. Perhaps grains of dust striking metal. Perhaps temperature shifts causing expansion and contraction. Perhaps something else entirely. Even the familiar becomes unfamiliar when heard on another world. Listening to Mars reminds us that every planet has its own voice shaped by its atmosphere, its composition, and its environment. If we could place a microphone on Venus, the sound would be thick and muffled by its dense air. On Titan, it would be slower, softer, more syrupy. On the Moon, there would be silence. And in the vacuum of space, no sound, only vibration awaiting translation. It is easy to think of these discoveries as scientific data points, as entries in research journals or mission logs. But beneath the numbers lies something more delicate. A feeling that for the first time we are beginning to perceive the universe, not just with sight, but with sense, hearing its faint traces like a sleeper, gradually becoming aware of distant rain. And with that awareness comes a shift in imagination. If the universe hums with plasma, sings with radio, and whispers through the movement of particles, what else might be out there waiting for the right kind of listener? For thousands of years we watched the stars in silence. Now for the first time we are listening to them. And the more we listen, the more the universe feels less like a void and more like a vast ocean of communication, sometimes chaotic, sometimes rhythmic, always alive. There is comfort in this thought, that Earth is not surrounded by cold emptiness, but by a tapestry of invisible waves, signals, tones, and pulses flowing around us continuously. Most of them originate from natural forces, from the very physics that binds the cosmos. But just as the first flicker of firelight in a dark cave once sparked humanity's imagination, these whispers too stir something ancient in us. Not fear, recognition. It may be that the greatest barrier was never distance, but perception. And now that we're learning how to hear, the universe feels closer, more intimate, more like a companion than an unfeeling void. As we prepare to drift deeper into the possibilities these cosmic signals represent, allow your breath to slow, your body to soften, and your thoughts to settle like dust in still air. There is more to explore, 3 paths of interpretation, each revealing a different way to understand the universe's voice. But for now, rest in the awareness that you are wrapped in layers of cosmic shelter, listening to a universe that has never been truly silent. Soon we will explore what these voices may mean, but first exhale gently, and let the silence between each thought cradle you like the space between the stars. There are 3 gentle ways we can interpret the whispers of the universe. None are absolute, none are complete, but each offers a different window through which we may look out at the cosmos and in turn look back within ourselves. The first interpretation is purely scientific, rooted in the physics of plasma, magnetism, and cosmic evolution. In this view, every hum, burst, and oscillation is a natural phenomenon. The 3 kHz tone Voyager recorded becomes a simple expression of charged particles vibrating in interstellar plasma. FRBs become the magnetic cries of distant neutron stars cracking under unimaginable pressure. The subtle sounds on Mars become dust wind, and temperature shifts across a machine exploring a foreign world. This perspective is grounded, humble, and beautiful in its own simplicity. It reminds us that nature, even without intention, produces harmonies of breathtaking elegance. We are listening to the universe's heartbeat in its most authentic form, unfiltered, unshaped, untouched by life. It is the sound of creation itself continuing to unfold. The second interpretation opens the door a little wider. It wonders if there are forms of cosmic energy or structures we do not yet understand, forces that ripple through space with patterns that appear random, only because our perception is limited. A tone lasting 3 years. radio bursts repeating from a single point in the sky, plasma waves forming consistent harmonies. What if these events trace the architecture of a universe more interconnected than we imagine, not supernatural, simply not fully mapped? Just as lightning once seemed magical until electricity was understood, perhaps there are cosmic weather systems or interstellar currents of information that we have only begun to detect. This interpretation invites curiosity. It encourages the mind to stay open to consider that the universe may operate on principles more elaborate than our current science can express. It is not about inventing answers, but allowing space for the possibility that some answers are not yet within reach. The third interpretation is the most imaginative but still gentle. It suggests that if life exists elsewhere and statistically across billions of galaxies and trillions of planets, it is difficult to believe we are alone, then perhaps some of these cosmic signals are signs of communication. Not messages directed at us, but signals moving across space for reasons or purposes we cannot yet guess. The universe is vast in both age and scale. Civilizations, if they rise and fall across cosmic time, could leave behind traces, echoes, or markers. FRBs repeating like beacons, rhythmic waves in plasma, patterns that feel intentional. We do not cling to this interpretation. We touch it lightly the way one brushes a feather with a fingertip. It lives in imagination's domain not to replace knowledge, but to remind us that wonder is a kind of knowledge too. And in the stillness of night, when people listen to Voyager's hum, or the recorded whispers of other worlds, some feel a sense of connection. As if the universe is not only observed but shared. These three interpretations, nature, unknown physics, and possibility of intelligence, do not compete. They coexist like three layers of the same melody. One is the note itself, one is the resonance, one is the meaning we feel when we hear it. And as this chapter gently settles like dust on a sunbeam in a quiet room, a peaceful realization emerges: the universe has always been speaking. We're only now learning how to listen. Let that awareness soften something inside you. Knowing that beyond our skies, beyond the heliosphere and the local bubble, beyond the reach of Voyager's fading signals, the universe continues to hum. Not for us, but with us. You are cradled in layers of cosmic shelter. You're surrounded by an ocean of invisible waves. You're living inside a universe that is not silent but alive. And as you breathe slowly, allow a gentle warmth to expand across your chest, an understanding that you are part of this great symphony. Every atom in your body was forged in a star born from the same cosmic furnaces that carved the local bubble long before Earth existed. The hum you hear now is not foreign, it is ancestral. We often imagine ourselves small, but to be made of stardust listening to the universe that birthed us is not small at all. In the soft quiet of this moment, imagine the final scene of this chapter. Voyager drifting farther into the dark, still listening, still hearing the hum. And somewhere ahead, beyond even our ability to imagine, lie other boundaries, other bubbles, other horizons of knowledge waiting to be crossed. As we close this chapter, let a final thought rest gently in your mind, like a lantern glowing faintly in the dark. If listening has already changed us this much, what will happen when we learn to answer? Let that thought drift with you peacefully as we prepare for the next chapter, where we turn from listening to journeying, from receiving to reaching outward, where we explore not the whispers of the cosmos, but the paths we may one day take to step beyond our bubbles and into the universe itself. For now, breathe softly and rest in the hum of the stars. There is a quiet moment in every long journey when the traveler pauses, looks back at the road behind them, and then turns their gaze forward toward paths not yet walked. Humanity now stands in such a moment. After listening to the whispers of the universe, after learning that the cosmos is not silent, but alive with energy and gentle signals, a question begins to bloom softly within us. What comes next? For decades, we have watched Voyager drift farther from the sun, carrying with it a golden memory of Earth. We imagined it sailing endlessly into the dark, an eternal messenger of who we once were. But a time comes when listening is no longer enough. The universe has spoken, it has sung, it has welcomed us into its quiet symphony. And now a tender curiosity begins to rise, an urge to take the next step beyond our cosmic cradle. If Voyager was a whisper into the night, then what comes next may be our first true reply. Scientists around the world are shaping the early dream of a new interstellar mission, one that could launch in the 2030s, a mission not just to listen from afar, but to travel deeper into the cosmic sea than any human creation has ever gone. A mission often described as the successor to Voyager, yet not in competition with it. Voyager was a beginning, This new craft would be a continuation of the story. Imagine a spacecraft born into a new era of technology, lighter, wiser, more capable, and designed with intention. A vessel not built to simply survive the void, but to learn from it. Where Voyager traveled on borrowed momentum and courage, this new mission would travel with knowledge, precision, and purpose. Its goal would be simple yet profound: to go beyond the heliosphere, beyond the influence of the sun, not just by a few dozen astronomical units, but by hundreds. To journey not merely out of the solar system, but into the deeper streams of interstellar space. To travel far enough that the heliopause becomes a distant memory, and the interstellar medium becomes a familiar environment rather than a foreign one. A journey not of thousands of days, but tens of thousands. A mission that may last 50 years or more. Perhaps long enough for today's children to grow old knowing that somewhere in the dark, a small vessel born of their time is still sailing onward. Picture, if you will, the spacecraft resting on a launch pad under a dawn sky. There is no rush, no urgency, only calm purpose. This is not a mission of conquest or competition. It is a quiet reaching outward, a hand extended into the night with curiosity rather than fear. The engines ignite gently, not roaring, but humming like a promise. And as it rises, the world below exhales together slowly, softly. Once beyond Earth, the craft would not race. It would glide. It would unfurl a sail, perhaps a solar sail catching the sun's light, or perhaps a sail guided by a whisper-thin laser from home, nudging it gently across the stars. No engines burning, no fuel running out. Just light carrying it farther and farther, as if the universe itself were breathing it forward. Inside the quiet heart of the craft, instruments would rest like listening organs, patient aware. They would measure the texture of space between stars, study the dust of ancient supernovae, taste the chemistry of the interstellar medium, and feel the magnetic tides that flow through the galaxy. For the first time, we would not be guessing about the space beyond our sun's reach. We would touch it, learn from it, perhaps even understand it. And if the journey continues long enough, the spacecraft may approach the outermost boundary of something we have only imagined: the Oort Cloud. A vast spherical shell of icy remnants from the birth of the solar system, scattered at the edge of the sun's influence like ancient seeds waiting in the dark. These frozen fragments may hold the very materials that gave rise to Earth, to oceans, and to life. If comets once brought water and organic molecules to our young planet, then the Oort Cloud is a kind of cosmic nursery, a memory of our beginning. To reach it would be like visiting the source of the river of life. The spacecraft may not touch an Oort object, not physically, but even passing through the outskirts of that region would let us read its particles, sense its chemistry, and learn whether life's ingredients are common in the universe or rare and precious. And while the world sleeps unknowingly under soft blankets and quiet breaths, a small craft would drift through that darkness, carrying not just instruments, but a message: we are awake, we are listening. And now, we are coming to meet the universe halfway. As you breathe gently, now imagine floating beside that craft. There is no sound, only the feeling of motion, steady, smooth, peaceful. Stars do not rush by like in films. They wait in eternal stillness, and the craft moves through them like a feather carried on a silent breeze. Behind it, the sun becomes a distant point of golden light. Ahead, the galaxy opens like a vast meadow under starlight, and in this soft journey, nothing feels rushed. The mission is not measured in speed, but in grace. It teaches us that progress does not need to be loud. Discovery does not need to be violent. Exploration can be gentle, like a hand touching water for the first time. As you drift with it, feel your body grow lighter, your breath slower, as if you too are leaving behind the noise of Earth. Let the image soothe you, a tiny starship gliding through a cosmic night, so calm, so endless, that time itself seems to soften around it. There is more to this story, more to the mission, more to the meaning of what it represents. But for now, rest here at the beginning of a journey that will change not only how far we can travel, but who we believe we are. The beauty of this new mission is not only in where it will go, but in how it will go. Unlike Voyager, which relied on gravity assists and finite power, the next interstellar craft will be designed with the wisdom of decades of exploration. Technology has evolved just as we have. Some concepts are already taking shape in quiet laboratories. Engineers imagine a spacecraft that can think for itself in a gentle, steady way. An onboard intelligence not loud, not human-like, but calm and observant, capable of making decisions when Earth is too far away to guide it. Signals traveling across light years take time, and so the craft must learn to be patient, adaptive, and independent. Perhaps it will have the ability to repair itself, to adjust its orientation using the soft push of light, the subtle pull of magnetic fields, or the faint winds of plasma, to rest when it must and awaken its instruments only when needed, conserving energy, the way a sleeper turns in their dreams. Imagine the craft encountering a region of space where particles behave differently, where magnetic currents shift or dust clouds shimmer with unknown composition. It pauses as if taking a quiet breath and listens. It studies, not rushing to conclusions, but feeling the environment the way a skywatcher reads the air before dawn. Only then does it send a whisper of data back to Earth, a message that will travel for years before arriving home, back on our small blue world, perhaps in a darkened room where someone like you is listening late at night. The signal will be received. And in that quiet moment, a scientist alone with their thoughts will open the transmission and feel a spark of wonder. The universe will feel just a little closer, a little more familiar, a little more like a place we belong to rather than fear. This mission is not meant to break records or claim glory. It is designed to understand, to explore with humility, to treat the cosmos not as a frontier to conquer, but as a vast ancient library in which we are privileged guests. Every piece of dust, every particle of gas, every shift in magnetic field is a page of a story billions of years old, and as the craft travels, the human story continues too. Generations will pass. People who watched the launch may one day tell their grandchildren, "I remember when it first left Earth." And those children grown older, wiser than their grandparents imagined, may look up at the night sky and know that somewhere out there, something built by human hands is still traveling onward. In this way, the mission becomes more than science. It becomes a thread woven through time, a lullaby carried forward across decades, soothing us with the knowledge that curiosity endures. For humanity, the act of sending a ship into interstellar space is not only an achievement, it is a declaration of identity. It says, we are no longer bound to our first home. We are a species that can dream beyond the edges of our sky. And yet there is a gentle softness in this dream. We're not rushing into the universe with noise and fire. We're gliding into it slowly, respectfully, like stepping into a quiet forest at dawn. If Voyager was our first small step outside the nursery, this new craft will be the moment we learn to walk beneath the stars. As you listen now, notice how your breath has slowed, how your thoughts have softened. Let the image settle in your mind, a small, delicate ship sailing through starlight, unafraid of the dark. Not alone, because your imagination travels with it. The journey does not need to be seen with eyes to be felt. You can feel it now like a calm wave moving through your chest. A sense that the universe is not distant but close. Not cold but gentle. Not silent but filled with quiet conversation. And as we stand at this threshold between listening and traveling, there is a warmth in knowing that our next message to the universe will not be a whisper carried on golden memory, but a presence, a touch, a meeting. The night around you feels softer now, doesn't it? As if the darkness has turned into a blanket rather than a void. The stars beyond your window, real or imagined, feel slightly nearer, calmer, more welcoming. Because the truth is, the more we learn about the universe, the less alone we feel in it. Soon we will let this mission unfold fully, step by gentle step. But for now, rest in this beginning, a beginning that feels like dawn even in the deepest night. The craft is ready, the path is open, and the universe is waiting with quiet patience. As the new interstellar craft moves farther from the sun, a soft transformation begins both for the tiny vessel and for the humanity watching from afar. The warmth of our star grows fainter behind it, like the glow of a candle slowly dimming in a long hallway. Yet instead of fear, there is a sense of peace in this distance, as though the craft is slipping deeper into a dream the universe has been keeping for us. In the quiet of interstellar space, the ship no longer needs to fight against the gravitational clutter of planets or the restless solar wind. The environment becomes calmer, thinner, almost serene. Here, beyond the sun's constant breath, the craft can unfold its sails more fully, letting starlight or laser-guided beams carry it with a grace that borders on the poetic. There is no rush. There is only the long, gentle glide into the deep. On Earth, decades will pass. Technology will evolve, languages may shift, and entire generations will be born who never witnessed the launch. For them, the mission will not be a memory, it will be a story. A bedtime tale told with awe, the way some speak now of the first moon landing of the early space shuttles or of Voyager's golden record. Parents may point to the sky and whisper to their children, there is something out there still traveling, still learning, and it was made by us. And in this way, the ship becomes more than metal and circuitry. It becomes a bridge of time linking past to future, linking the people who dreamed with the people who continue to hope. One of the most precious goals of this mission is its potential to reach the outskirts of the Oort Cloud. Not its center. The distances are far too vast for a single mission, but even touching the edge would be a first in human history. The Oort Cloud is like a shell of icy fragments surrounding the solar system, a boundary of ancient debris that has existed since the dawn of our cosmic home. These frozen bodies have remained almost untouched for over 4.6 billion years. To study them is to read the oldest chapter of Earth's origin. Some scientists believe that within these icy fragments lie the same building blocks that once fell to Earth and carried the seeds of life water carbon compounds amino acids. If true, then visiting the Oort Cloud is like visiting the wellspring from which life on our planet first drank. It is a journey backwards and forwards at the same time, back to the beginning of everything we are, and forward into the possibility of finding life elsewhere. As the craft sails closer to that region, its instruments would awaken more frequently. They would sample the particles drifting through space, tiny dust grains that may have seen the birth of the sun, or survived the explosions that carved the local bubble long ago. Each particle holds a story, a whisper of how the galaxy formed its stars, its planets, its living worlds, and the craft will gather those whispers gently, like a traveler collecting letters from ancient ruins. But the interstellar mission is not only about what we will learn, it is also about what we will become by daring to learn it. For the first time, humanity will not just receive the universe's voice, we will walk toward it. Voyager listened. This mission will listen and move closer. Like two minds leaning toward one another in conversation, the distance between listener and speaker subtly shrinking. For anyone following the mission, whether scientists, dreamers, children, or those who simply love the night sky, it will offer a sense of rooted calm, a feeling that humanity is doing something gentle, thoughtful, and profoundly meaningful. Not for power, not for competition, but because curiosity is part of who we are. As you imagine this moment now, let your breath slow. Feel the calm that comes with thinking about a journey that spans decades, not driven by urgency, but by patience. A mission that allows time to stretch and soften, as if the universe itself was singing a lullaby for humanity. In this stillness, the ship continues forward, quiet, steady, unafraid of the dark between the stars. With each passing year, the interstellar craft will drift farther through a realm no human eye has seen. Stars that once clustered tightly in familiar constellations from Earth will slowly rearrange themselves into new shapes. The idea of home will stretch not as a place with borders, but as a feeling carried across light years. Deep in interstellar space, the sunlight becomes too faint to power traditional systems. But the craft, designed for endurance rather than haste, will rely on energy harvested from the environment itself, perhaps through tiny radioactive hearts like Voyager once used, or through next-generation systems that sip power slowly like a candle that refuses to go out. Over time, even Earth's languages may evolve. New music, new dreams, new problems, new joys will shape our world, while the craft travels steadily onward. Yet in the background of our collective memory, the mission will continue, an ongoing, gentle thread connecting generations. Those born long after the launch may find comfort knowing that something created by human hands is still out there moving with purpose in the dark. There is a tenderness to such endurance. Like a letter written by ancestors to descendants they will never meet, the mission becomes an act of love sent into the future, trusting that someone will one day read what it discovers. Along its journey, the craft will cross regions where the interstellar medium changes in density or temperature. Some areas may be filled with dust that glows faintly under cosmic rays. Others may be nearly empty, like long pauses in a song. It will learn to navigate these subtle shifts, adjusting its sails or orientation like a traveler, turning their face to catch a gentler wind. Occasionally, small streams of particles will brush against its instruments, remnants of ancient supernova explosions that once echoed across the galaxy. The craft will taste these particles the way one might inhale the scent of a place visited for the first time, quietly noting the details. And Earth will wait patiently for each whisper to return. Because of the vast distances, each message from the craft may take years to reach us. Some transmissions might take a decade. Imagine a child hearing news from the spacecraft for the first time at age 6. Then the next update arriving when they are 16. Their understanding of the universe will grow alongside the mission, as if the spacecraft itself were maturing with them. This slow rhythm of communication will teach us something precious, the value of patience. In a world often filled with urgency, noise, and constant motion, this mission will remind us that the most meaningful journeys unfold quietly at the pace of the cosmos. And perhaps as the craft approaches the faint outskirts of the Oort Cloud, humanity will change in a subtle way. For thousands of years we looked at the night sky and saw mystery, fear, beauty, distance. But knowing that we have reached out not just with telescopes but with presence will soften something deep in our collective heart. We will no longer feel like observers of the universe but participants in it. Just as a child eventually steps beyond the doorway of the home where they were raised, humanity will step beyond the boundary of our solar cradle, not to abandon it, but to understand our place within something far greater.